Welcome to Matematika. Today we're going to do 1.11a, equivalent representation of polynomial and rational expression, part 1. I'm dividing this content into two parts, and I'm focusing on part 1 about the standard form and the factored form of polynomials. Polynomials can be expressed in two primary ways. So it can be expressed in factored form and in standard form. Actually, all of these are a review of what you have learned in Algebra 2. And then we are going to go over this and combine the characteristics of a polynomial functions. So each form exposes different properties of the function and can be converted from one to the other. Like you write in standard form from a factored form or from a standard form to a factored form. So the factored form of a polynomial, this is the product of linear terms. Okay. So you can see that its term is linear. So when you have a product, then you have it in terms of a factored form. So this can be expressed in an f of x equals a times x minus r sub 1 times x minus r sub 2 and so on until x minus r sub n, where r sub 1, r sub 2 are zeros of the function. Okay. What can we get if we have the polynomial in terms of a factored form? So in this form, we could easily get the real zeros, okay, in this form by setting its factor equal to 0 and solving for x. And that x corresponds to the x-intercepts on the graph of the function. So converting a polynomial to factored form allows us to easily identify the real zeros. Okay? Easy for us to identify the real zeros. To convert a polynomial form from factored form to standard. Okay? This time, when we convert factor to standard, we multiply out the factors and combine like terms using the distributive property. Okay, we use the distributive property here in converting from from factored form to the standard form. So the standard form of polynomial, we have a sub n times x to the power of n plus a sub n minus 1 times x to the power of n minus 1 until a sub 1x plus a sub 0, where n is non-negative integer and each a is a coefficient. Okay. I have an example here of a standard form like function of x times x plus 3 times x minus 2. If we want to convert that to standard form using the distributive property, using the FOIL, multiplying, we come up with f of x squared plus x minus 6. Well, if you are given a polynomial times a polynomial or trinomial, three terms like this, 5x squared plus 2x plus 1 times x squared minus 3x plus 5. Okay, it will take a somewhat like time to do distributive property here, we have a very long line of terms, and then we come up with this 1, 2, 3, 4, 5 terms. Okay? So 5x to the fourth minus 13x cubed plus 20x squared plus 7x plus 5. Later on, we're going to talk about how we're going to multiply, like a polynomial to polynomials, and then making it in a shorter way, having, by using a certain method where we can multiply it quickly. Okay, let's have an example here. Write a polynomial expression in standard form for the perimeter, okay, perimeter of the rectangle shown. So when we say perimeter of a shape, that is the sum. Remember, perimeter is the sum of its length. Okay, we say side length. Okay, so we have one side given is 1/2 x plus 0.4y, and the other side is given as 1.6x plus 9/2y. So if we are going to add, this will also be, if this is 1/2 x plus 4y, this is also 1/2 x plus 0.4y, and the other one is also 1.6x plus 9/2y. Okay, so by adding, if we add this, let's make it short by making it like, okay, the perimeter, since there are 2 of this and 2 of this, so might as well we can write that as 2. We call this the length and the width of a rectangle. So coming from the formula, like 2 times the length plus the width, okay? So what will be our solution there? We have 2. So what is our length is 1.6 x plus 9/2y plus the width, which is 1/2 x plus 0.4y. Okay? We have a fraction. So might as well we'll take out that fraction by making it decimal, since we have decimal values here. Okay, let's do this. 9/2 is 9 divided by 2, that is 4.5y. And 1/2, that is 0.5x plus 0.4y. So everything now is in terms of decimals. So collect terms. So 1.6 plus 0.5, that is 2.1x. 4.5 plus 0.4, that is 4.9y. Okay, so we'll use a distributive property by multiplying its term by 2. That is 2 times 2.1, we have 4.2x. 2 times 4.9, we have 9.8y. That is by the distributive property. In case you don't know the formula of the perimeter, so what do you think you're gonna do? You're going to do the long way of adding it, right? Or you can do like saying, I have two of this, right? So 2 of that, you will say 1/2 is 0.5x. plus 0.4y. And then I'll add, I have 2 of this. So you're going to add 2 times 1.6x plus 4.5y. You can do that. You can do that. Okay? So by doing that, you can still multiply and expand. So 2 times 0.5, that's 1x. Okay, the 2 times 0.4, that's 0.8x. 8y. 2 times 1.6, that is 3.2, right? X. Then you have 2 times 4.5, you have 9y. All right. So collect the x. Okay, your x is 3.2 plus 1, that's 4.2x. Then plus collect the y, you have 9.8y. So you are getting the same result. Whatever method would that be, still you come up with the same result, so long as the process is correctly done. Consider the following function. H of A is equals to 3 plus 2A to the third power. So rewrite H of A in standard form. Okay. So because this is an expression, we can rewrite the exponent because the exponent say 3 times. So we can rewrite it as 3 times. Repeated multiplication. Then multiply each term 1 factor by each term in the next factor. Okay, let's do this. Say, for example, you have H of A plus 3 plus 2A to the third power. So what we usually do is that we multiply 3 plus 2A 3 times since it is to the third power, right? Okay. So you can do the first 2 and do FOIL. So you have 3 times 3, that's 9. 3 times 2A, that is, okay, 3 times 3, that's 9. 3 times 2A, that's 6A. Then 2A times 3, that is 6A. 2A times A, that is 4A squared. Then 3 plus 2A. By simplifying, you come out with 9 plus 12A plus 4A squared. Then that's the time you're going to do FOIL again. No. You do distributive property. FOIL is for 2 binomials. So you can expand by multiplying each term again. Okay? Like 9 times 3, start with that. 9 times 3 is 27. Then 9 times 2A equals 18A. Then 12A times 3, that is 36A. Then 12A times 2A, that is 24A squared. Then you do 4A squared times 3, that is 12A, that is 36A. Then 12a times 2a, that is, okay, I mean 4 times 3. All right, I'm okay, sorry for that. I messed out. I am on the third term. 4 times 3, that's 12a squared. Then 4 times 2a, that is 8a to the third power. Okay, by arranging and collecting terms, you have, okay, I see the highest term, 8a to the third power. How about 8 to the second power? I have 24 and 12. So that is 36a squared. And the a is 18 and 36. I have 54a, and the constant is 27. Right? That's the way how it should be done. You have to, multiply it one by one by each term, and then do the distributive property. But later on, there are several ways or strategies how to do, expanding the term when it's a factored form. Noted that the leading term right here is found here. It's not actually the leading term in the polynomial, but we usually arrange them according to the degree. Okay, since the higher degree is 3, then 3 should come first in the final product. Okay, identify the y-intercept of h of a. Now, the y-intercept, the first thing that we have to look at is the constant term of the function when it's written in a standard form. Okay? So the constant here is 27. Okay? That's the constant. So the y-intercept is found at 0, 27. That is the location of the y-intercept. So if we are going to substitute the value by checking, substitute the value of x in this polynomial right here. So we say 8 to the 0 cube plus 36 to the 0 squared plus 54 times 0 plus 27. So we have a 0 plus 0 plus 0 plus 27. Our value is 27. And that is the y-intercept. So how do we do the y-intercept again? Making the x value equals 0 in the function or in the form, in the polynomial. Describe the end behavior of h of x. So if we try, let's go back. I have to look at our polynomial here. 8a cubed plus 36a squared plus 54a plus 27. Again, we have to review how to get the end behavior. What we're looking for is the degree of the function and the leading coefficient. So degree and leading coefficient. That's the one that will determine our end behavior. So our degree here is 3. So the degree is odd. all right, and the leading coefficient. Okay, what is our leading coefficient? Is it positive or negative? Coefficient. Our leading coefficient is positive, that's 8, positive 8. Okay. What is odd and positive? So, what will be our end behavior here? Remember that, you know, the limit as x approaches positive infinity, the h of x is equals to positive, and the limit as x approaches a negative infinity, the h of x is negative infinity. That is when it's odd and then it's positive. Okay? Remember the table I had given in the other videos. All right. So what I can say in this standard form, we can use, okay, we can use, I have to highlight this, the distributive property. So in the example I've shown, we use the distributive property to convert a polynomial. What kind in a polynomial? In factored form to standard form. Okay? So what we are doing here in the first part, okay, we are converting a factored form to a standard form. So let's go now to the second part, which is the factored form of polynomial. Factoring a polynomial is a process of expressing a polynomial as a product of its factors. So, in other words, it is the inverse process of multiplying polynomials. So, we have learned several or different strategies, including the identities before in our Algebra 2, and that can help us factor a polynomial. So, okay, one way is factoring using the greatest common factor. All right. So, greatest common factor is, remember the very popular GCF. A greatest common factor from its term of polynomial is factored out. Like this, you have ax plus ay and so on. So a is common. So a is factored out, and what remains inside is the x plus y. So for example, we have 3x plus 3y. 3 is common. So we factor out 3, and what remains is the variable x plus y. So factoring by grouping, second strategy is factoring by grouping. That's a method for factoring an expression containing at least 4 terms. Okay? So when you can see your polynomial, it has 4 terms already, then you can start factoring by grouping grouping the terms in pairs and taking out the common factor. Like this, you have ax plus ay, bx plus by. So a is common in the second one. So a you factor out, and b is common in the second, in the last two group. So you factor out b, then xy. And what is the common factor is x plus y times a plus b, the coefficient. So for example to that, okay, so example we have 2x squared plus 8x plus 3x plus 12. So we have four terms, so we can start grouping this. Okay, we can start grouping it. So by doing that, you have to look at what is common between 2x squared plus 8x. So you can see the common is 2x. You factor out or taking out the common factor. So our common factor there is 2x. So 2x squared divided by 2x, you have x. 8x squared divided by 2, you have 4. Alright? Well, the other one, the common factor between 3x, this is 3x plus 12. The common factor is 3. You factor out 3, and then x, 12 divided by 3, that is 4. So by looking at the common, you can see a common factor. So x plus 4, and then you add the two coefficient and make it as one factor, 2x plus 3. That is what we mean by grouping. I know you have learned this already. So this is just a reminder or a review what we have gone through. Factoring by quadratic trinomial. So a trinomial can be expressed as the product of two binomials. Like you have an ax squared plus bx plus c, then you have mx plus p and nx plus q, where m and n is equals to a, pq is equals to c, and np plus mq equals b. Let's visualize it, how it looks like. In a simple way, I know you don't like the m, the n, the p, and the q, so let's make it simple. For example, you have x squared plus 5x plus 6. Okay. So what do we mean by c? If we have a p and a q, p times q, that would be the equals to c. Okay. You have to find a factor in such a way, the factor of 6, in such a way that when you add them, you can get the middle term. That is what we mean by NP plus MQ equals B, the middle term. Okay? So 1 times, because our coefficient here is 1 times 6 is 6. So what are the factor of 6? 6 can be factored as 1 and 6, 2 and 3. No more, no less. So which one will give you, when you add them, will give you a 5? 2 and 3, right? So in other words, our factor would be, we split the x, since this is all positive, so all plus, one factor here and the other factor of 6. Then that is the factoring the quadratic trinomial. Okay? Perfect square trinomial, perfect square. Okay? A trinomial is found by multiplying a binomial by itself. Like you have a squared plus 2ab plus b squared. You have a and b, okay, inside the parentheses and square. Or if you have a squared minus, what's the difference between these two? This is plus and this is minus. 2ab plus b squared, so you have a minus b inside the parentheses, and that is squared. So, for example, we have x squared plus 10x plus 25. 25 is a perfect square, right? You don't have to get the factor, but you know it's a perfect square. So what you're going to do is split. These are all positive. So split the x plus, all positive, no problem with the sign. And what is the square root of 25? It's 5. So split that too. Or you could say that this will become x plus 5 squared, since there are two of them. Or if you are given like 4x squared minus 12x plus 9, okay? All right. You have a perfect square. Your coefficient here and here. Perfect. But since the middle is minus, then you have split a 2x and a minus sign. Square root of 9 is 3. Square root of 4, that's 2. So you have 2x minus 3 squared for perfect square trinomial. I hope you remember all of this. Sum of two cubes. Do we miss out the difference of 2 squared here? I will add this later on, the difference of 2 squared. Okay, let's proceed. All right. Sum of two cubes. A plus B, A cube plus B cube equals A plus B. This, you factor this out. And the second factor is A squared minus AB plus B squared. You have to be careful. If this is plus, the factored trinomial is minus, but the factored out is plus. Okay? So this will be, for example, I have x cubed plus 8. 8 is a perfect cube. That means 2 times 2 times 2. That means x plus 2. That is your cube root of 8. Then you have 1 degree down from x cubed. So that would be x squared. And reverse the sign. If this is plus, the sign here would be minus. Then 2 times x. 2 times x, that is 2x. Then 2 squared, that would be 4. Okay? That would be the other one. Difference of two cubes, the result of perfect cube. If there is sum, then there is also a difference. So what's the difference here? When you factor out, they have the same sign, but the polynomial, the second factor, is the inverse or the opposite sign. So for example, we have 1 minus 64 y to the third power. So 1 times 1 times 1 is 1. You factor out. And 64 cube, that is how much? 4 times 4 times 4. Right? Okay. So that is 4y, and the factor out is 1 cube, 1 squared, 4 times 4y times 1, that is 4y, and we have 4y squared, that is 16y squared. And this is how the difference of two cubes looks like. I think we missed out the difference of two squares. I'm gonna write the third one here. I hope I have a space right here. So difference of two squares, the result of a perfect square, okay, being subtracted from another perfect square. Being subtracted from another perfect square. So, for example, to that, um, example is a squared minus b squared. Okay, so that would be the sum of the a and b times the difference of a and b. That's the difference of two squared. So for example, I have x squared minus 25. What will be my sum and difference? It will be x plus the square root of 25 is 5, and x minus 5. That's the sum and difference of two squares. Okay, sorry for that. We messed out that in our listing here. All of this you have gone through in the Algebra 2. I hope you remember this stuff, because we'll be using this later on. Okay, consider g of x equals 6x to the fourth power minus 10x cubed minus 24x squared in factored form. So rewrite in factored form. Now, first of all, we have to look at the GCF. Okay. Usually the first thing, that's why it is the first in our listing here. Let me go back. Different factoring using the greatest common factor, GCF. Because I was looking at here 6, 10, 24. So there is a common factor between the three terms. So I think I could do like factoring out by 2. I cannot do by 3 because 10 cannot divide by 3. Okay? And how about the x? Get the lowest degree of x, and that would be your factor in case there is a series of terms that has an x value with different degrees. So get the lowest degree as your factor, greatest common factor. So 6x to the fourth divided by 2x squared. You have 3. 6 divided by 2 is 3. X to the second power. 10x cubed divided by 2x squared. You have 5x. 24x squared divided by 2x squared. You have 12. Okay. We have to find Um, okay, so we have to deal with the second factor here. 3x squared, we have to simplify that. Minus 5x minus 12. We try to factor more. Okay, so by factoring, um, we cannot use the perfect square trinomial, but the quadratic trinomial. Using the quadratic trinomial. All right, so we're gonna do like 2 times 36, A times C. 3 times 36. So 3 times negative 12. What's going on? That's negative 36. I keep on thinking about the negative 36. So the B would be, the sum should be a negative 5. That would be your lookout in what you're going to factor out. So what are the factors of 36 that when you add them, you come up with a negative 5 in the middle? So in 36, we have 1 and 36, 1 and plus, 1 and minus 36. It doesn't add up to negative 5. We have 2 and 18, doesn't add up. We have 3 and 9. Okay, we have 3 and 6. It doesn't add to 5. 4 and 9. Okay, 4 and 9. So our factor that we can use is 4 and 9. We have to find out which one should be into a negative, since our middle term is negative, so B9 should be a negative. So in other words, we factor this out as okay. So this is what we're gonna do. You have 3x squared, then plus 4x minus 9x minus 12. Because when you do that, when you try to expand that, you come up with negative 5x. Okay, so what is common if we try to use this by grouping? So in 3x squared plus 4x, the common is x. So we have 3x plus 4, right? And here, the common is negative 3. We have 3x, change the sign. If we're going to do this, change the sign. This would be 12 by 3, that's 4. So what is our common? X minus 3. The common factor, common factor is 3x plus 4. And the coefficient is x minus 3. So in other words, all of our factored form, put them together, would be, the first one is 2x squared right here. Then the other one is 3x plus 4 and x minus 3. These are the factored form. You can check this if you are getting it right by multiplying it back and do the distributive property. All right. Identify the zeros of g of x under multiplicities. So, finding the zero, you have to equate the form equals to zero, right? So in other words, we have our g of x. I have to raise this up. In factored form, we have 2x squared times x minus 3 times 3x plus 4. Right? So we can start equating each one to 0. Okay? So, of course, that would be equals to x is equals to 0. Then we have, what's the other one? X minus 3 equals 0. X is equals to 3. This is the second one. And the third one, 3x plus 4 equals 0. So 3x equals negative 4. X would be negative 4 over 3. These are the zeros. Okay. So in the factored form of the polynomial, this is the second part. The factored form in the polynomial and identities, we can use fully factored polynomials by factoring using the GCF, factoring by grouping, factoring quadratic trinomial, perfect square trinomial identity, difference of two squares identity, sum of two cubes identity, and difference of two cubes identity. These are the identities that I'm talking about. The perfect square trinomial, you can have that identity, and sum of the two cubes, difference of two cubes, sum and difference of two squares. Okay, difference of two squares. This is also identity. You can add up. Okay. So, we are done with the first part of 11.A. In the next video, I will be doing the second part. We'll focus more on this part about polynomial division and also that is the remainder and the factor theorem. Okay. Let me say this, if I can do it, so can you. Please don't forget to hit the like button and the subscribe button. See you in the next video.